Good morning. To the birds of a feather. Well, this actually started out as a one-on-one with Christian, and it was like, oh, you won't be the only one interested, and let's, yeah, whatever, let's do a birds of a feather. Just with any birds of a feather, you're not going to learn anything here. I'm just going to, yeah, or maybe you will. Yeah, that's right. I'm not going to tell you anything or educational about the SDK. We're going to talk about SDK. We're going to talk about our plans for SDK 6.0. Right? It's not often that we do major versions, and I think that's a good thing. But it doesn't mean that we're slowly batching up on stuff that we really like to do for SDK 6. And I just want to highlight a few. Martin and I actually prepared. Look, here it is.
That's our slides.
Yeah. I mean, the usual stuff, I'd say, we always, as soon as we find something that's a breaking change, we update our issues. Well, we do this tag in our issues. So if you filter on breaking change, that's some of the stuff that we're going to do in 6.0. It's actually that's actually quite a lot. Or maybe.
I think it's half of it.
But some of it is already, I think, some of the things I typed here is about the other plans that I have for 6.0, which go a little bit beyond simple breaking changes. The good news is, as you can see, that we only have 54 issues left. The way we did that is by moving quite a lot of them out to the validator repo that we now have. That helped. Next plan is, we can have a Firepath repo and move everything out. And that's no, but also we have.
We've done a lot.
We've done a lot, and we have a new junior guy who's fixing all the bugs. That's been a while, like since we had that on our team. So that's great.
He doesn't go to meetings and anything.
Yeah, he will at some point. Yeah, that's right. He never has to do PowerPoint slides and all the crap that we get to do. So he actually can work on bugs, and that's surprisingly effective. So we're in a good shape, and that's why we started thinking ahead for what do we want to do. Shall we start thinking about SDK 6? So, the breaking change things we'll do, which in the context of our SDK means breaking as far as compiler. We try compiler compatibility normally, right? If we make a change that and you can't compile your stuff anymore, that's a breaking change for us. It's not a binary breaking change. We do those in minor versions, although I don't know how long we'll be able to do that because there's people starting to complain about that. So what we have done in our build is added we've added a build step that detects binary breaking changes, and that just makes you realize how hard it is to remain binary compatible. Because I think in every single, now we do a pull request and we get like, oh, pull request failed. What's going on? Oh, a binary breaking change. That's really hard. But we just started that to get us mentally ready for what's a binary breaking change. But so if this is marked breaking change, I mean, you can compile the stuff anymore. There's this gray area we realized where we're the kind of, ourselves, we always turn warnings into errors. And then, of course, what's a breaking change gets a little bit more iffy, especially when we've also started a big project adding nullability everywhere. And these are normally warnings. But if you, like us, do warnings as errors, then you will get some errors, probably in minor versions of the SDK. So that's those are the easy ones. We'll just go over this list and see what we can do. You can check those yourselves. But it's much more interesting to talk about the bigger changes that we want to make. And some of these have been cooking for quite a long while. In our heads, we didn't really know how to make progress on them, and so the best thing to do if you don't know, if you're stuck, is just to let them simmer for a while. And a while became about a year and a half or so, but now I think I'm ready to show a few of those. If you were at the Dallas meeting, you've heard most of this already. But one of the bigger things I'd like to introduce, we like to introduce in the SDK 6 is unifying POCOs and I-typed element. Because for us at least, it feels like we have two stacks to maintain at this point in time. We have the whole POCO stuff. That's the things that I started out with all by myself 14 years ago when I did the first version of the SDK. And I think that's still, some of the most popular bits. I think what people usually use is the Fire client and the POCOs. And there is, of course, the I-typed element stack that is useful if you want to be fully dynamic. So our Filey server does everything with I-typed element because that allows you to just drop in structure definition in the admin interface of Filey server, and then boom, you have a new resource, right? There's no precompiled things, nothing. But it did mean that, like resolution of canonicals, equality, comparisons, all that stuff we have to maintain and do twice and keep in sync and keep consistent. And another thing that starts to be really important for all of us, I guess, is the first 10 years, it's not that performance wasn't important, but performance is getting more and more important. And I-typed element being like a very flexible dictionary thing is not fast. It consumes quite a bit of memory. So I think for a lot of things, if we want to speed up, we want to use the POCO side of things. And I'd just like to, just to get an idea of what, no, I don't want to copy, extend. Yeah, here we go. So currently we have, let's not forget about that. We have two sets of parsers to maintain, right? The faster ones that go from JSON straight into a POCO, and then the slower ones that go from JSON and XML into typed element. Source node first, nice. You don't know whether it was JSON or XML anymore. Then typed element, nice. We have type information associated with it. And then first, I think that's a public class scope node because typed element is like, you can go deeper, but you can't go back up. Scope node adds knowledge about parent resources, so you can resolve things and so on, contained resources. And then validator. And all these things are wrappers, and they add GC pressure, extra classes, and so on and so on. In fact, every single time, this is also all lazy. So every single time you go over the children, you go deeper, we enumerate the stuff all the way back from there, and eventually you get parse errors if there are. You only get them when you actually, because it's lazy, when you actually go through the tree. So when we were doing the new validator, we said, what shall we do? Shall we write it against POCOs or against I-typed element or actually against scope node? We'll get that even in the new validator. We'll be held back by this whole stack of lazy, inefficient stuff. So what the new validator, one of the things that I wanted the new validator to do in any case is make sure that we parse the whole scope node first. So we actually read the whole scope node into element node, which is a class that already existed for a long time, and it takes an I-typed element and just consumes the whole thing in memory, one big DOM document, and then moves through it. But if that's the optimal situation, then I'm like, okay, so I already have everything in memory. Why not have POCOs? Well, okay, POCOs are, you can just read the stuff that is correct, right? Resources that you know about, nothing else. So we were going back and forth between the two when we were doing the new validator. And the same is actually true for Firepath. We're like, what are we running Firepath against? Firepath is also running against scope node. So, and then we get the SQL engine on the SQL SDK. That came from a different direction. That was donated by NCQA, and that is fully based on POCOs. So like, oh gosh, we got two stacks, the equality thing, the comparisons, everything. We implemented everything twice, or maybe even thrice, because you got the CQL comparison logic, you get the Fire comparison logic, and they should be the same, but are they? And in the SQL engine, that got all re-implemented. So this is not an ideal situation. It's not really bothering anyone. It works, right? It's not, but it bothered us for a long while. And so even though in January we pushed the publication of the new validator, this is still in there. In fact, most of this is also still used in parts of the SDK that sometimes parse. For example, the directory source, and there must be a few others, like maybe the npm package source. And a few versions ago, certainly the Fire client, they used the old parsers that do this whole source node typed element instead of the newer parsers. We already started to change that in SDK 5, I think, where at least for the Fire client, you can choose which parsers you want to use. So there is now an abstraction called iFire.
Serialization factory.
Yeah, iFire serialization factory, right? Yeah, that's it. iFire serialization engine, actually, I think. That abstracts away from which parser family you're using, basically, and you can configure the Fire client with that. Which is nice. Which also means that the Fire client currently has to assume, because that interface did not really prescribe the type of exceptions or errors you would be getting back. So the Fire client is like, oh, if that's an old parser family, then I recognize the parser errors like this. And if this is a new parser error, I recognize the errors like this. So there's one thing we will do in any case, and that is go over the whole SDK and make sure that we use these newer parsers everywhere, or at least use this new Fire serialization engine. So you can swap out your favorite parser or even write your own. There's always people who say, oh, now I know how to code generate. I'll generate my own parsers, but I love to use the rest. So being able to switch out parsers is a good idea anyway. But what we are going to do also is probably sync the errors between the new parser set, which has nicely structured errors with codes and so on, and the old parser set. That's something that that we'd like to do. Those are the easy parts.
Definitely.
Yeah, but it will save. I think it's time to switch out the old parsers. They are.
Slow.
They're slower. Yeah, and there's no way we can. Well, we can make them a little bit. We will. That's also on our. At least that's on our wish list. We also like to make those a little bit more performant, because when I initially wrote these, I wanted them to be so flexible that they could take in CDA document or total crap XML and still be round trippable. Nice, but we never used it, and I don't know if anyone does. And it does add to the memory pressure and the slow parsing and so on. So we probably will slim down our current, the older source node and typed element parsers to ditch most of that flexibility, or maybe keep the ones that we have now, because they can sort of do CDA, but not really, I think. So, well, Alexander tried, but in fact, I think we're better off that if you want to if you want to do CDA based on iTyped element, write a CDA parser based on iTyped element. It's an interface. You can write you can write an implementation against iTyped element. Now we have a parser that tries to do everything under the iTyped element flag. And I think simplifying that code will also shave off a little bit, at least some memory. And while I'm saying that, I realized that while I was in the US, one of my colleagues, Christian, who is on the Filey server team, who's the tech lead on the Filey server team, said, oh, I already did some experimentations with the POCOs and this, and there's really something you need to see. So I'm like, whew, that's a cliffhanger. I have no idea. He's currently busy doing the performance stuff in Filey server. So he's... yeah. He found that the slowest thing, for example, in our FirePath, and so we use FirePath obviously to do the indexing for the incoming data. I saw Brendan's talk yesterday about insertion. That's a big thing. That has to be fast, and so indexing the FirePath stuff. So Christian had been busy finding out why that was slow. And the surprising thing is the slowest thing there was our UCOM library. Oh. Yeah, so you could optimize everywhere, and then it turns out your UCOM library is the slowest one. By far, which is fair enough, because that UCOM library, it's fire.metrics, I think that we call it, was created as a weekend project by one of our employees who like, oh, this UCOM stuff is really cool. Let's write a UCOM parser for it. But that's about it, and then it turns out to be really, really slow. So that's one of the things we're currently working on, speeding up that UCOM parser. So that should speed up everyone's FirePath indexing and so on and so on. So, yes, go ahead.
Did you guys look at the the issue with the validator running, like even in ostrich mode, it still runs the validator, it just ignores the errors versus just not running the validator at all. We found that was a large part of why deserialization was taking a really long time for us.
You can set the validator to null.
Yeah.
Set the validator to null, because you can
Yeah.
like ostrich mode is supposed to ignore any of the errors, but it still runs the validation.
Yes, I
it just
think
doesn't return
I
them.
think one of the I think this is in our issue list somewhere.
Is
Like
it? Okay, I
we're
think
still
Evan
doing
might have
things in
submitted it.
ostrich mode. So there are a few errors we still collect and then just throw away, which is a bit of a waste, or maybe more than a little bit of waste. I think, for example, it might be that in ostrich mode we still have maybe even the narrative XML validation on, which is certainly very expensive. Yeah, that is also there. So there's that, and I think that we have that in the.
Yeah, if you pass in, sorry, Brian was saying that you can null the validator and then do it for the recording.
Yeah. So I'm thinking in ostrich mode, all the errors are ignored, I think, but
They're
you still
ignored,
get the
but
list.
yeah, you're still getting a list
And
because
that might be informative, right?
I think that's a clear delineation between the null validator, which is saying don't validate, and ostrich mode, which says validate, but I don't care about errors.
Yeah.
And so, yeah, I
But
think that's a good logical
And even if
distinction.
we choose to keep that, it might be, I don't know if we document it well enough that you can set this to null. Like so, maybe
I'll go ahead and assume we don't.
We should have ostrich super performance. We could also have like an ostrich super performant mode. Just
Yes.
what the heck,
Yeah.
I just wanted data. Anyway,
Give them a data mode.
give me
It's
my
already
data
been-
mode.
It's already been validated, so yeah.
Yeah, we have a pre-processing validation step, and now all we want is the performant grab it out of the database part.
Yep.
All right, so speeding up for a while we were like, so we have, the code base is pretty stable. We know the requirements that we have on the end of scope node. Scope node serves most of the purposes, the things you need to implement Firepath, I think CQL, and validation. And so at first we were like, okay, we're going to turn scope node into iScope node, and then make 2 implementations for it. And one of the most important requirements that are in scope node is the ability to move back, right? So there's a parent. And we need that because you need to be able to resolve canonicals. And if there's an error somewhere, you like a nice location path. Right, and those are 2 really, really important use cases. So you have to be able to get to the parent. I mean, we puzzled whether can we ditch the parent, right? And we tried even in the validator. What if the validator kept track of the location instead of the instance? Then you don't need location on the instance, and we could ditch the whole parent thing. But then you get down to your first resolve call with a contained resource or whatever, and then you have no clue where you are anymore, or you're jumping through the instance and you're like, what's the path now? So we really need that parent. So what I did during my holidays in Mallorca, as anyone would do, is, let's see, this was problem 1, our big pipeline. Sync errors between the parsers. So this document, by the way, if you wanna read, I'm just more or less summarizing what's in this document. So this is in our wiki. I don't know if you've seen it. If you go to the FireLiNet SDK, we do maintain quite a bit of wiki pages there. And unifying POCO and iTyped element is kind of the root document that was my brain dump during my Mallorca holiday. On okay, these are the problems. This is what we need to do. And one of the things I did is an inventory of the requirements. So that's this link here. So I went over CQL, validation, Firepath, and wrote down all the requirements we would have to this like new super I scope node, whatever, that would fit all the requirements. And so navigate to the parent is there, navigate down, that's easy, right? We had that. iTyped element had that. Convert values to CQL types, that's necessary for CQL and Firepath both. know the element name. Well, there's a lot of obvious ones, but the parent one is hard. Locate the nearest parent resource, resolve internal references, determine equality, blah, blah, blah. We have some of them, but it turned out that neither the POCOs nor I-typed element have all of them. And so we're like, okay, that's the situation. What do we do now? And my preference was to not have to implement the extra requirements on I-typed element and on POCOs.
So I typed POCO.
I typed POCO, right. But POCOs are already typed. So we let that simmer for a while. And also, and that's the good thing about having like a semi-holiday working trip to Mallorca. At some point I was, why won't we have a thing that I think you and Brian also we discussed, why won't we have a thing called dynamic resource? So that's a POCO. It's a subclass of resource. And let's throw in a dynamic data type too, and dynamic primitive, who knows? And that stuff is not based on built-in generated elements, but those are based on dictionaries. It's not that dictionaries are inherently very slow. It's just the stacking of all our I-type classes that are slow. And in particular, every time you enumerate the children, it would be nice if you get back exactly the same thing, and all of that is true in POCOs. If I say we already implemented I-read-only dictionary a long while ago, and if you say, what are the elements in this POCO, every time you do that, you get the same children back with the same references. So it's very easy to compare them. Whereas in an I-typed element, every time you do get children, it will internally have to, it builds a new wrapper class and returns all that crap. So POCO simplifies a lot here. And I was like, what if we go once over it and we implement all these requirements on the POCOs? I think a lot of people will like it, and that's something we cannot do currently. If you are somewhere in a POCO and you say, resolve this canonical. But we don't have a resolve function on POCOs currently because there is no parent. And so one of the biggest things we have to make that work is have a parent in the POCOs. And that's a big thing. That is the biggest thing. That's the scary thing. We need to be able to implement these requirements on POCO. We need to be able to move up and have a parent. And I can do that in lots of places. But yeah.
Can you speak a little more about the dynamic primitive?
Yes, of course. Yeah. There's two big things. So dynamic resource, I think, is going to be a resource that implements all the base stuff from resource plus a dictionary. And we already have I-read-only dictionary, and I-read-only dictionary implemented on this dictionary is a trivial thing. And on the plane here, I also implemented just the full dictionary on the POCOs. And so to be able to set them and work fully through a dictionary, whether it's a POCO or not. And then what we can do is when we parse, and we encounter, you could actually during parser maybe say, okay, this is a custom resource that I don't have. Can you parse this into iDynamic resource or dynamic resource? And you get something back that will have all the methods that implement these requirements, but then the properties aren't hard-coded properties. There are dictionaries instead. So this allows you to use custom resources without requiring I-typed element. And that was, of course, the whole point of this exercise. Can we slowly ditch I-typed element for custom resources, which is an important use case for us? And yeah.
Oh, I was just thinking through on the read-only dictionary and the other one, are we using the fire element name or the property name?
The fire element name.
We're using the fire element name. And for choice types, did we add resolvers so that if you say, give me deceased Boolean, it knows to map to deceased? If not, we should add that.
It is in the dictionary, it is deceased.
Yes.
Yes.
So we should add the virtual, if I ask for deceased Boolean, to give me deceased if it is Boolean.
When we designed I-read-only dictionary, this was a discussion, and we decided not to do that. So it only recognizes deceased, and you get the POCO back with the given type, right?
Yeah.
And for dictionary,
I guess that's how Firepath does it too, right? Yeah.
Yeah. And for dictionary, I had to do something else. If you do a try try add value on dictionary and it's not the correct type, one of the choice types, then you get a false back from the try. That's what I did now, although I think the documentation said that the try returns false if the element is already there. So I don't know if that's exactly the correct behavior. All of this is a little bit, we're still like trying out what will happen. Maybe do I have to throw an exception saying this is not one of the allowed choice types to make it really explicit? Could do that too. Yeah. And so the use case of custom resources is covered by this, because then the parser will return a dynamic resource with the custom resource stuff, and every custom resource in the end will use the Fire data type. So probably we could write this parser in such a way that at some point you just you don't stay on the dynamic side, you just get down into the normal Fire types that are already there, because even custom resources are built out of the normal data types.
Sure, you've already started thinking with C# 13, with extension properties on already closed classes, then you can actually, even in the dynamic resource, add properties for your first class things that can reach underneath, so you can get the full POCO style thing on a dynamic resource then.
Well, yeah, I watched the presentation at Build, and this is one of their major examples, right?
Yeah.
Extension clause on dictionary, and then actually at settable properties, and so this is something that happened after I did all this, and I was like, that's actually, and for your generated POCOs for the profiles, it's also something you can do to represent extensions as normal extension properties. So that's super cool. Another thing why you would use I-typed element is because you encounter errors, and I think our POCOs currently are good at capturing incorrect data in primitives, right? If you parse a Boolean and it doesn't say true but true or a misspelling, the object value behind all the primitive classes, the primitive POCO classes, capture the value in a thing called object value, and that's of type object. And the current parsers either put the real thing in there, so if it's a Fire Boolean and it's bool, it will be a bool, but if it's not a bool, it will put the raw string value in there that's on the wire. That is something we did gradually, and I did add another issue to our tracker to really rethink that actually, because we're using object value for two things: either the real value that it was there, or the raw value that was on the line. So I do want to take a moment, I think, when we're doing 6.0, whether to reconsider whether we should actually have like raw value and object value.
Yeah, I'd say if we call it original value, then it aligns with the extension, and when we serialize it, we can put that back on as well.
Yeah, yeah.
So.
Yeah. So that's that. But other things like unknown elements are a bit harder. I could put them in a dictionary, but you wouldn't have any, like, probably they would be maybe dynamic data types, but you wouldn't have any type information, right? Because if you don't recognize it, what do you put in there? So that's something that I don't know what to do. I do have confidence that I can capture custom resources with this, but I don't know exactly what to do with errors if I don't have any type information. You could just say, okay, well, we'll go back down to a dictionary that has one-on-one the data that was there, and good luck with it. Something I want to try out, and if we have any intelligent ideas about that is.
I can give you ideas.
Yeah.
I don't know that they're intelligent. We'll iterate.
Yeah. And I know we've been thinking about this for a while. And then at the Dallas meeting, someone said, okay, can't we have that dictionary on the normal resources too, right? If I parse a patient, the normal POCO patient, and I encounter an element that I don't know about, can't we put it in a dictionary? Or even if I encounter an element and I do have the type information about this, and that in this case that would mean in our model inspector, for example, or even maybe in the old I structure definition summary provider, if in some way, because coming out of a structure definition or because of reflection on something, I have the type information, then but it's not in the POCO itself, just add it to the dictionary. And this is going to make sense, I think, from R6 on, where you probably want to say, my application is normative R6, and if there's on a 6.1, 6.2 that only will add elements to it, put them in the dictionary, right? And then we could add extension packs, or you could write extension classes to reach out to those. There's all kinds of flexibility things we can do there.
Yeah, I think, and obviously we want to loop with Christian as well, but especially when we talk about dynamic resources and new properties, I think those, we should put them kind of into the same bucket as far as adding ways to register, oh, here's a class you can use that adds the additional new things to patient or encounter, because that's probably more likely. And you can use the same type of thing for custom resources, and that way you can get that unified view downstream.
Yeah, yeah. Is that what I was? Correct me if I'm wrong. What I was thinking about is to have the parser. If you invoke our new parser, that you be able to provide some kind of policy to it to say, if I encounter something that I don't know about, here is a callback to call, and I'll decide the kind of class to generate, and whether to go the dynamic data type way or insert this class that's mine, or
Yeah, and that's why we can play with whether it's the factory model or the discriminated type model or different things like that.
Didn't you half had that with?
I half had
with source nodes.
Yeah.
Because source node is like dynamic bag of stuff plus the type information from the I summary information provider thing.
Yeah.
Then you get the typed element.
Yes.
So you.
So you're right.
If this one is providing custom or more information, then type element sort of understands it downstream. I mean, I know that's not the way that it works, but it could.
No,
right?
it could, and in fact, I mean, I'm framing this discussion now on the JSON parser, but in fact, what I did on the plane here is implement it as an I-typed element parser, right? So, given an I-typed element or an I-source node, produce this dynamic resource for me. Because, as you say, we have this whole infrastructure there already. In fact, it's built deeply into Filey Server and probably many other pieces of software. So to make, and also yours, so there, and Simplifier as well. So it's good that you mentioned that. I have no plans ditching I-typed element, I-source node, nothing of the sort, right? We're going to sync the error codes, clean the code up, try to make it faster, and prepare it for eternity. But I want to provide this, instead of having this whole stack of adapters, to have a kind of parser step that takes your I-source node or I-typed element and brings it into this dynamic resource world, then implement all the requirements once, and be very optimized and performant on the validator, firepath, et cetera, et cetera, et cetera.
I like the direction.
Yeah, because that uses the existing infrastructure we have, right? Yeah.
Right. Yeah, it makes sense. I mean, I think for a file server, most of the time, you're just looking to get that bag of JSON into something that you can run Firepath on.
Right.
However that happens.
Yeah.
But then sometimes you actually need to basically build a POCO. If I want to return a bundle, I need to do that somehow.
Yeah.
In C#. And there's also a few other cases where you parameters object is another one. I know that's sort of more easily shared now in the more recent SDKs, but previously it was either POCOs or the highway, you're on your own.
Yeah.
So there's been progress.
So I think So I think this transition indeed makes it possible also for Filey Server, which uses I-typed element everywhere, or maybe I source node with some extra tricks. I think because then you don't have to type it all the way, right? But this way you get to POCOs and then be able to serialize it. Well, serialization is a different beast. I mean, the current serializer uses I-read-only dictionary, and I could conceive implementing that very efficiently. Well, we do that actually already on top of I-typed element. There is I don't know if we do that actually, but we could implement I-read-only dictionary on top of I-typed element, so you can just pass it straight into the serializers. just for because like that's that use case.
Yeah. Yeah. I mean, it's software. Anything's possible.
Yeah, but dynamic resource, in the end, this whole setup makes it possible to, in those parts of the software where that's where you want that, is to slowly migrate to the POCO stack without giving up the flexibility of I-typed element, and having a faster parsing stack and the less memory footprint and blah blah blah, the whole shebang.
And I'm excited about the other direction too, that when I do have a POCO, I don't have to go down to the scope node
Right.
on the fire.
Right. Because that's true for a lot of people, right? That's why in the end I think yeah, those are the main users. That's why we didn't choose, because we could have to say, let's stay on the I-typed element stack and build a the scope node thing, build it out and so on, and then too bad for the POCOs. But POCO users are like our biggest user base. So yeah.
Oh no, I was just saying I'm a POCO user.
Yeah.
My bad.
So it felt more natural to build this on the POCO side of things and make a very easy upgrade path from I-typed element there than the other way around.
Is what we all.
Christian.
So-
Oh, for you. Otherwise you won't be on the recording. Here you go.
So all of these POCO, right? You basically discover the POCOs via the model inspector.
Yeah.
So the plan is, if it's not registered in the model inspector, you just use a dynamic resource.
Yeah. Oh no, I have my own mic. No, I think. So the model inspector currently gets its information from the POCOs. So one thing we need to do is to think, how would it be? So if you have a custom resource, how would we get that type information into the model inspector without actually having a POCO class for that custom
For
resource?
us, the way we currently do it, we get the model inspector and then we add the class mapping.
Yeah, you could do that.
Yeah.
But class mapping has tons of properties that are, well, class mapping has grown away, it's grown too big. So it's good that you mentioned that, but because that is still something that's completely in the back of my mind, is simplifying class mapping, or at least making visible that to be able to use these dynamic resource parsers, you don't need to have a full class mapping, but maybe just a subset, right?
There's a way. Import type was the one we used. Yeah, it was import type, and it generates the class mappings. I think using.
It does, but what if it's a custom class that you don't have a POCO for? That's the case that I want to. You need to, right? Or you want to specify, I have patient, but expect these 4 extra elements,
Yes,
right?
and
You need to be.
That's where I'm curious, especially with C# 13 stuff, if we can add in kind of factory things at that level to say, here is our 8 patients, because we've added a few more things, and then can we derive enough information there if we have that extended set of properties, and make that class responsible for ensuring that they're annotated properly, and then just use the stock serializer and parser.
One thing I've been thinking about is, since the later versions of the system text JSON stack, right? There is a JSON type info of T.
Yes.
Which actually exactly has the subset of stuff that is necessary to, I think, to make dynamic resource work. It has enough information. It has the type information, and it has a factory property. Like if I'm parsing this, at some point I need to be able to create an instance of this stuff. How do I do that? And that's all. That's all in JSON type info of T.
Yes.
I think.
I thought you were saying for serializing, because it does have everything you would need for the JSON serializer, but it still doesn't have the order for the XML serializer, because the JSON doesn't have the order. So we would have to extend or add or keep those in a sorted list or something.
Or No, or,
Oh, you heard it. It's not on the recording. We had from the
I don't
crowd.
know. Or, oh no,
ditch
sorry,
XML.
custom resources are not supported if you're using XML. I don't
Yeah.
know. That's hard,
Yeah.
right? Because you still, well, we can't really ditch it. People
No,
will bring
but
in XML.
whether that's annotated
Yeah.
or sorted or because you can just put a
Yeah.
static list at the top of your class that has the order in it, and then we don't have to annotate. We just use that order for the traversal order and.
Yeah, we all know. I'm looking at the class mappings and all that because there's a lot of stuff in here that I'm not sure that we still need, or we could do differently. And then you start cleaning up. It's like, nah, we need it anyway. And order
Yeah.
is one of these things where I put like, it was a nice theoretical idea to use IJSON type info of T, but there's
Yeah.
things missing there too. Yeah.
So
So
keep order.
so one of the things we do need to do is get this. So this was actually a very long answer of can you go deeper into dynamic resource? Yes, that was this one. The other one was getting this. One of the requirements is getting to the parent. And so I can of course add a parent property to base, right? But it won't be filled automatically. Someone has to do that, and I think we all know that there's always these edge cases like, I can change the property setters that if you set a property, I set your parent, that's fine. But the hard thing is list. If you add something to a collection, currently, it's just a normal run-of-the-mill .NET list class. And it won't set parent for you. And list is in our public interface of POCO classes. So the only way to solve this is to, some folks at NCQA have been suggesting this for a while. Why don't we use iList or some list class that I can extend? Because list is not extendable. I could have done this if it was not list, but something that's extendable. So I could, conceivably make a fire list thingy that has like on insert, on add, whatever. So if you wanted to do different stuff, I'll set the parent for you, but if you want additional things, create a subclass of this, and that's what we're using. Or we could use iList, or maybe the span thing that I haven't looked. Well, I know what span is, but yeah.
The spans are more for the consumption because the point is to avoid iterating, so that you can say like, oh, I have a list of 100 elements, but I'm only iterating over these 5 or something like that. If you pass it in as a span, then you're not doing bounds checks and all those other things that are expensive, and you're not doing an allocation because that's a common thing. You copy your 5 elements out of your bigger list. And so that's why it's great for all of those things. So I think, yeah, some combination of iList or whatever for what we store and track, but then making sure a lot of our extended functionality based off of spans instead. And
Sure.
then whether you're using array list, iList, whatever, then the span works on all of them.
But if I make it iList and someone sets it to a normal list again, then the parent property won't be set again. So I need to think maybe, so I might have to actually hard type that new list property anyway, but then make sure that it's an extendable class if you want to add custom things. Because for example, in bundle, I had multiple use cases. For bundle, I would have loved to be able to specify different behavior for bundle entry. Because for big bundles, sometimes it's nice to have like a cached index on element type, or maybe a normalized URL within the bundle, or these kind of things. It would be very useful if you could get your hands behind when stuff gets added to a bundle. I want to run some code.
Yeah.
And that is something we could enable. But this is.
Yeah, you can play. I was playing with that a few months ago, and you can do that with if you make like iFirelist, and then that type is an iList, and you add the thing where you say like in your class it's iFire parentable or whatever, and so then you can add those as the restrictions on that interface, and that way people can make their own as long as they still have those interfaces.
Well, and as long as they set the parent property as soon on the add, right? That's the thing I need to enforce.
Yep.
Although I I still hope that one morning I wake up and I discover a better way. But for the last 30 years that I've been making software, I know that keeping a parent property on a child thing, when you edit or set a property, there's always going to be some corner case where it's not being set or whatever, or you set it on two things, and of course, it will wipe the parent. You will not belong to the parent of the other one. There's always something
Shallow
going
copy
on.
versus deep copy, and the parent's wrong because it's pointing at the originator and all that kind of stuff.
Yeah. But it is one of the, I don't like it, but it's one of the things I need to do if I want to go full POCO, because that's the only way I can make Resolve work, as far as I know, and and create a location for a random spot in an instance. And the other major question that I'm not decided on, and that I would love, your thinking power is, this means that the main abstraction is going to be like dynamic, base actually, or resource. You can, when there's a dynamic resource, you can write all your code against resource, because that will have everything. But then the question is, that's still a class. Should we introduce iResource that has, the things that are required that I wrote down here? So iResource has a parent, and it has it implements iDictionary and so on and so on and so on. All the stuff that resource does now. But then if you don't want to subclass resource, you have a code generator that does something else entirely, you could still try implement iResource.
Yeah, we need to tinker. Because I like the idea of it, but also when you start playing that game, a lot of the code gets ugly because you need to start adding explicit casts in different things.
Yep, most of the time. Yep.
And you start getting a lot of ugly code that yes, I know this is an I resource, but it's actually a resource, and then you put it in a link statement, and the link statement's like, oh, I don't know how to convert from resource to I resource, and you're like, no, it's an I resource, trust me.
Yeah.
And so then we start adding lots of typecasting and all that kind of stuff.
It's definitely not trivial. And don't forget base. You write a code generator. There's a lot of stuff we currently generate on each subclass for it to be able to implement iRead-only dictionary, iAnnotatable, iDeep comparable, iComparable, all that stuff. There's a lot of things you need to do before you can participate. And so that's the last thing that I made this too. Like what have we collected over the years in things on the public service of resource? And there's actually quite a lot. And I think some of that can currently be written as extension methods against iRead-only dictionary. So for example, iDeep comparable is things we don't really need anymore. We could use the normal, we could write an pattern, an iEquatable, pattern, and implementations could be pattern equality, exact match equality, and so on. And you can write that against iRead-only dictionary. So there is definitely a way to make the surface leaner and have less stuff to generate if you want to add your own POCOs.
Yeah, and I think we can steal a lot of that from record classes and structs, because they've refined a lot of that clarifying whether you're doing shallow or deep comparisons and copies and all that different stuff. So I think there's a lot of infrastructure and interfaces built up around that for record classes now.
Yeah.
So we should be able to steal all that.
Yeah, and in general, I think, and that's what Evan did in the CQL engine, is use way more of the iEquatable, iComparable interfaces instead of iDeep comparable that I did myself.
Yes.
Exactly. So you had to, and I was like, but we have that too with pattern comparable and exact, and there's always use cases for. But I want compare without being case sensitive, and having an iComparable infrastructure matches that use case better, I think.
Yeah, and I think it also opens the door easier for us to start adding some of these comparers into the SDK, because I noticed that I ended up writing a lot of comparers for fire sort orders, because I need to, the lengths versus the periods when you're comparing paths and all that kind of stuff. That's annoying, and it's just fiddly to write once, but we should probably put those in the SDK.
All right. So there's a lot of plans for SDK 6.
Yeah.
Did I mention that we'd like to make structure definition, push it back down to base? No kidding. So that we have one structure definition class across all versions of Fire. That would be super cool, right? If we can pull that off.
Okay.
And I think we can.
I think we can.
We can, I'll say, because I've written that, I use the iSource node parser to convert, like I can read a DSTU2 structure def and give you back an R5 structure def.
Yeah.
So we can do
Yeah,
that.
we can.
I don't know that it's 100% yet, so I'd be terrified of that.
We're doing it from STU3 to R5.
I have 2, 3, 4, and
Yeah. Yeah, because structure definition is currently in conformance, so it's the same for R4, R4B, R5, or 6 already, but not
Yes.
STU3. So, and it would be really nice to have structure definition the same everywhere. So
Yes.
there's a few more things. We started doing that in SDK 5, pushing this conformance,
Yes.
and I think we'll add a few more of those. Value set would be lovely, but I don't know if we can pull it off. There's a few more. So that's just
when I
like-
have all the code
yeah.
for too.
So that's the weekend work, the real work I discussed, right? Like
Yes.
do the parents.
Question.
Yeah.
What kind of time frame are we thinking?
Next week.
And I'll ask some, I'll do a why after because it's funny.
So there's I think, a realistic technical answer that I'd love to give, and that is, given all this and the think work that we still require to do, let's work on this, say, Q4-ish, right? Start to work.
Okay.
I've already started working on this, like trying stuff out, but maybe actually implement it Q4-ish. So that's that's one answer. But our Filey server friends are going to push out a new major version in Q3, and they can only upgrade to a November. Oh yeah, they can only do a major upgrade of the underlying SDK, and that's probably true for like for our if you write an extension against Filey server, you use the SDK too.
Yeah.
And they only obviously do a major SDK upgrade on a major Farley server upgrade, and that timeline is November.
Okay.
But I'm not going to push. If it doesn't work before November, we'll just like.
Oh no, I think
we'll
that's probably
slower.
good because I realized when you had your breaking changes up, some of the changes that we merged last week
Yeah.
into the source generator are those breaking changes. So the source code we were trying to go for, making sure we had all the exemptions for the R5 to not have breaking changes, and it doesn't matter because you already included the XHTML primitive and all that stuff.
Yeah. Yeah.
And so we don't have to worry about breaking changes
Yeah.
in that version of the source generator.
So that's so no.
Because we'll have we already have breaking changes.
So
that
I
I'm
don't
not
know
gonna
if you
roll
think
back.
that's too fast or too slow, but that's what we currently have in mind.
Oh no, it's just I wish we would have realized that last week because all those patches we were putting in to say, yes, we're detecting this better. I refactored all of the code generator, and there's some things we're doing better now. Especially I get to take advantage of things like the terminology expansions that are built into the SDK. And so before I had to hand write all of my expansion code, and I had some different corner cases than Firely had and things like that. And so when we went through and started analyzing like, oh, when can we start using this? We said, oh, but that's a breaking change. So even though we've detected this better,
Yeah, right.
here we need to put in this patch to give us the SDK 5 version of the behavior. And we didn't have to do any of that because XHTML is already breaking, and so we can't use this until we move to 6 anyway.
I don't think the XHTML is breaking, but
You have it listed as a breaking because it's changing the primitive type. It's changing it from string to the new primitive type of XHTML.
I don't think it does. But
Yeah, you added
so
a new
no,
primitive
but
type.
actually I was like, yeah, we need to. For now, we need your code generator to not break the SDK because we're still going to
Yeah.
publish a 5.8, 5.9, 5.10 because we're going to.
Yes.
Many of the changes I discussed today, there's a lot of things we can prepare step by step before doing a breaking thing like
Yes.
like the list thing.
But I think we're going to have to use the old version of the code generator because I don't know how to unroll those changes.
We'll see. Let's discuss that offline.
offline.
Okay, thanks for your attention.
you.